I've got a couple announcements, everybody, and then we're going to take some notes. I'm going to try my very best to have this done at 11:30, 30-minute mark. So let's get cracking. I've already spent some time. So announcements real quick. All right. All of you, I've talked to you about this last week, and I sent out emails. Everyone, if you haven't already, have Unit 1 and Unit 2 completed by next week, Wednesday. That's next week. So we've got a week and 2 days, the 17th. A lot of you have been working really hard in the last week, and I've been seeing you come to office hours. I've been hearing Brandon say, "Oh, this student came and met with me and got another mastery test done." I love hearing that, and I see you guys, folks, doing it on your own too. So I'm seeing a lot of you make a lot of progress. So I'm going to do some congrats in just a second, but I really am grateful and happy to see so many of you working really hard to get caught up on Unit 1 and Unit 2. The deadline is next week, Wednesday. If you want to stay in the class, which I do want you to, but I can't proceed with so many people not trying to finish their work. So that's why I'm doing this deadline, okay? So please work hard and try to get caught up on these 2 units. Let's see. Just as a reminder, what I'm asking you to do to make it simple is the mastery tests and the post tests from Unit 1 and Unit 2. So if it was too confusing doing all the other assignments I made, forget about it. Just do the mastery test and post tests. Okay, just a reminder, 3 p.m. tomorrow on Tuesday is extra help time with me. So if you want to meet with me at 3 o'clock, I'm going to put you and the other students into separate breakout rooms. If you're open to it and if you're working on the same work, maybe we'll try doing group work tomorrow in the tutoring hour, but no worries. You don't have to. I won't make you if you don't want to. Either way, I want you to join me at 3 o'clock and we will work on our mastery test and I will come around and help you on your different questions. Same link, okay? The same link you just joined me with now is how you join me tomorrow, Tuesday at 3 o'clock. It's not in person, it's on Zoom using the class link. Okay, also contact Brandon for extra math help. He's our math tutor. Some of you have. That's awesome. I'm so glad you are doing it and taking advantage. His email is bdwonch, BDWONCH at ofy.org. So to set up a time, just write him an email and say, "Hey, my name is Josiah. I want more math time help from you, and I was told I could do that with you." And he'll write you back today and say, "Hey, totally. What time do you want to do it?" So he's very nice, very easy. Take advantage of his time. He's offering it to all of you. So if you're stuck on a mastery test or a lesson and you want extra help, and you're coming to meet with me on 3 o'clock tomorrow and you need extra help, talk to Brandon, okay? Talk to him today. Don't wait. Any questions so far on these announcements, please? No questions. So everyone's on board and understands. Okay, real quick, I want to acknowledge the hard work of all those of you who I've seen working hard on your own, turning in mastery tests and catching up, or people working with Brandon and catching up, or working with me last week and catching up. And I'm seeing a lot of you finish up Unit 1, which is great. And some of you are now wrapping up Unit 2. So high five to you guys. So I am going to call out in some positive way all of you who I see catching up. So Brooke, I see you almost finished with, I think, Unit 1 and Unit 2. So nice job. Philmon, I've seen you do almost everything so far. So great job. Moose, catching up. I love it. Unit 1, I think. I didn't write these down as to who has gotten how far, but I was looking at it earlier. So I'm not making it about if you're done with both yet, but I'm just trying to recognize all the hard work you're putting in, and I'm seeing that hard work. So don't stop. Joseph is actually not here right now, but Joseph, good job. He's almost caught up. Anthony Ravelis, Anthony R. and Anthony T. And Anthony T. You two are almost caught up too. Nice. Robel, good job to you. Making a lot of progress over this last week. Don't stop. Keep working hard. And who else? Anaya, I saw all that work you did. You're doing fantastic. Almost done. Levi, I think, did catch up all the way. So high five to you, Levi. Beniam, I saw your work too. Good job. And then Victor, I don't think is here with me. Darn it, Victor, where are you? Should be at class. But I saw the work you did. Is Victor here? No. Must have slept in because of daylight savings. Anyways, good job to all of you who have been working so hard. Don't stop. Let's keep working this week on Unit 3 work and catching up on Unit 1 and 2. Take advantage of my time tomorrow and Brandon all week, okay? All right, let's jump back in. So today I want to do slope and graphing. Slope and graphing from Unit 3. So this is the first lesson in Unit 3. So I'm going to show you 4 or 5 different skills that we need to get through this mastery test. And I'm going to try to have it done in 20 minutes so that way we can start our mastery test. I'll put you all into your own breakout rooms and you can get to work on it. If you want to write me a chat after we get started and say, hey, I would like to work with someone else, then I am going to start putting people into small groups of maybe 2 or 3, and you can work on it together. But for today, I'll do that at your request. So if anyone wants to work as a small group, you write me a chat message and we'll do it as a small group and I'll put you guys together, okay? And then I'm going to come around in a circle and check in with all of you while you're working independently. Okay. So let's see. Let's start with this. So what is slope? We already know like what graphing means. It's to graph a line. And we have graphed lines making tables before in this class. But what is slope and how can we use it? Slope is a number describing the steepness of the line. So it's a number. It describes how steep the line is. Says how steep the line or the function is. I should call it the function, how steep the function line is. We're talking about functions here, and how steep is it? The function line is. So for example, if you've got a really steep looking one like this will have a high slope number. Now I'm making up an example. I'm just kind of pulling out of the air. Let's say that this is a high slope number. Maybe this is a slope of 20. And we'll compare that to a lower slope number. What does that picture look like? If you graphed a lower slope number, it's tilted downward more. So this would be a lower slope. So maybe this is something much lower, like a slope of 5. So in general, if we're given a bunch of different graphs and we're to compare the slopes, if it has a higher number for slope, that means it's a steeper line. If it looks more flattish, like the one on the right, that means it's a lower number, like 5. Something lower than the steep one. Any questions right now? Comments? Concerns? All silent. No questions. So also, what if our slope number is negative? I didn't leave a lot of room here, did I? To show negative slopes, those lines are going downward. I'm going to do a new screen. So a negative slope number is going downward from left to right. So for example, maybe this slope is -3. I'm kind of pulling these numbers out of the air just for example, okay? We'll do some like real math examples in just a moment to find real slopes of real functions. Okay, no questions yet. Let's talk about the definition of slope a little further. Um, it's actually defined as rise over run. Let me write this down. This is important. It's a fraction describing a rise number divided by a run number. And rise means a change in heights, change in like how tall the 2 points are. So a change in height over the change in distance. That's what my code words of rise and run mean. And here's what that means if we were to have a picture for a function and its slope. So graph with me for just a moment. Let's look at an example graphed out. I'm going to make it go up to 5 for x and 5 for y. So 1, 2, 3, 4, 5. Remember left to right line, that's our x-axis, and the y, the vertical, going up and down. So 1, 2, 3, 4, 5. Okay, graph with me. Do your best. It's okay if it's not perfect. Now, for example, let's say we had 2 points graphed on our blank graph. I'm going to change my color to purple. Let's say we had one right here. And what is that location? What is the coordinate of that point? Can anyone tell me? Can you see that? Or is it too small to see what the coordinate is?
1 and 1.
1 and 1. Who was that?
Anaya.
Anaya. High five, dude. Thank you. Yes. So 1 to the x, if I look down, I can see like that number that she got for 1. And then if I look to the left over here, I'm seeing the other 1 she got. Okay, let's say we also had the point 4 comma 3 graph. So that's 4 for x, 3 high. So it's roughly right about here. Do your best. It's okay if it's not perfect. And we're going to label that 4 comma 3. Okay, so there's 2 points kind of floating out in space, right, on our graph. 1 comma 1 and 4 comma 3. Where does slope come from? How does that figure into any of this? Well, to find the rise, what I'm doing is measuring the height change between my 2 purple points. So let's go ahead and connect the 2 dots with a line. This will be our function line. Trying my best to make it straight line, but it's a little curvy. Okay, so there's our function line. Remember, when we graph a straight line, that is the same thing as a function. When we have been working with y equals 3x plus 2 or some equation like that, that's a function. That's the same thing as our purple line here, but graphed out as a picture. Um, so to find the rise over run, the change in height and the change in distance, we're basically just measuring between the 2 points I picked. I'm going to change my color quick here, 1 second, to green. So let's do change in height. I'm basically looking at point 1, okay, the 1 comma 1, and then looking at point 2, 4 comma 3, and I'm looking how many squares, how many units up do I go? Up 1 unit, up 2 units. That's how high the next point is, the 4, 3 point. So my height change is 2 squares. 1, 2. change in height is 2. And then we're doing the same thing from left to right to find its distance change. So I'm starting from that same like leftwards point, and I'm going unit by unit till I kind of reach how far the second point is. So that's how far it is. It goes to the 4. And now we want to count squares. So over 1, 2, 3. Going from left to right, it's 3 units over. So the distance change is 3. Okay, so if I put those together as rise over run, over on the right side, let's do that. Rise over run is 2 over 3. So the slope of this function is 2/3, or 2 over 3. So that's how we can find slope with a picture. If they've given you a graph, we can count the slope using the units or the squares from one point to the next. Now, what if they don't label the 2 points? Well, then it's up to us to find 2 spots to count from, okay? And frankly, you can use anything on the picture. Any points on the line will always give you the same slope. But it's best to find spots where it's crossing over the whole numbers. Like I have mine here at 1, 1, whole numbers, and 4, 3, whole numbers. So it's our job to look at the equation, the function line, the purple line, and decide, okay, where is this crossing over like the whole numbers spots? So I can count change in height and change in distance. Okay, I'm going to move on and do another skill. Any questions on this? No questions. Okay. Take a picture with your phone or your screen. And just so you know, I am going to post this PowerPoint later. I'll put the video up, and I'm working on doing a Google Classroom so you guys can just like log in and find the PowerPoints themselves. So don't stress too hard if you don't get it all copied down right now. Okay, it's okay to take a picture as well. Here we go. So next up, I want to talk about slope, intercept, form. Slope, intercept, form. So some of you may have heard this before, maybe not. It looks like this. Y equals mx plus b, okay? The m stands for slope. M is slope. And the b spot, the b position, stands for y-intercept. So when we're working with our math, we're not going to be given equations that actually have mx plus b, the letters. There's going to be numbers in them, like this, for example. Maybe you're given one that looks like this. Y equals 4/3 x minus 5. So I'm making this example up, but that's what our equations will look like. The slope is 4 over 3. The y-intercept is negative 5. I haven't told you what y-intercept means, but you could probably get an idea of it. We know what the y line is on the graph, and we know what intercept means in football and in rest of life. Intercept means kind of like crossover, or I guess in football it means, one team stops the other team with the ball, right? And that's what's happening with the function in the y-axis. The y-intercept number is telling you where to start graphing. So here's my blank graph. So whatever that plus or minus b number is, in this case it's minus 5, we can start graphing the function at minus 5 on the y-axis. So down 1, 2, 3, 4, 5. And let me make some more units here, and then we'll actually graph it. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, let me change my color to purple real quick. So if I was given an equation like y equals 4 over 3, x minus 5, it's slope-intercept form. Basically, all we're looking for is that it says y equals, okay? If you can solve it so it says y equals, then the number multiplied to x, that's the m number, that's slope. And the number that's by itself without an x, the minus 5, that's the y-intercept. So you start by going on the y-axis, the middle vertical line, and finding the b y-intercept number, negative 5. So that's right here. That's my y-intercept. And then you follow slope. Slope is like the map telling you where to go next. It says it's 4 over 3, which is rise over run. So I'm going to count up 4 squares. So 1, 2, 3, 4. Up 4 puts me right here. And I'm going to go 3 to the right. So over 1, 2, 3, right here. Whatever that spot is, that's my next like good place to stop to make my line, or make my line, my function. And what is that spot? That's over 3 down 1. So if we had to label it, it's at 3, negative 1. Let's do another one. Up 4 over 3. 1. I'm going upwards 4. Up 1, 2, 3, 4. And then over 3. 1, 2, 3. Stop. Now I'm doing this by hand, so my graph's probably not perfect, but look, I think I did a pretty good job of having those 3 points come out in a straight line. They should come out in a straight line because we're always going up 4 over 3, up 4 over 3. That's our roadmap. And if you connect them, that's the function. So if we're graphing and it's in slope-intercept form, that just means we've solved it for y. So it says y equals the rest of it. Y equals stuff. Y will be by itself. Okay, if it's not in y, if it doesn't say y equals, it's not in slope-intercept form. If it's in slope-intercept form and it says y equals, then the number multiplied to x, the 4/3 here, that's slope. And the other number is our y-intercept. Where the purple function is intercepting the y-axis, where it's crossing. Let's do a quick side example of this same skill. I'm going to move on, new screen. Example. People are dropping out of the group. Darn it, what's happening? Example. What is the slope of the function? I'm going to say find the slope. And here's our function. Negative 3x plus 8y equals 12. Now, this is scary because it's not in y equals form, is it? It doesn't look anything like what I just showed you. Our job is going to be to solve it for y. Solve this for y. That means make it say y equals the rest of it. That means get y all alone. How do we get y all alone? We've got to undo this minus 3x, and then we've got to divide by 8. Since the beginning, I've been telling you guys, identify what's happening to the variable that you want to solve for, and then do the opposite. So here, we've got to get rid of this minus 3x, and we've got to get rid of this timesing of 8. and then y will be all alone. So let's do that here. So I add 3x to both sides. And then we want to divide everything, left and right side, by the number 8. So 8 over 8 cancels. That's why we did that. Now it's solved for y. Yay! Y equals, it still doesn't look quite like the other example, does it? 12 over 8. Can I reduce that a little bit? I can. It's half would be 6 over 4. Half of that would be 3 over 2. So I'm going to reduce my fraction. I cannot reduce 3 over 8, though. So that's stuck as 3/8x. Now, these aren't even in the right order. It should be the x number first and the 3 over 2 afterwards, right? But it doesn't matter. We're still looking for which numbers with x. That's 3/8. That's our slope. The other number, the 3 over 2, that's the y-intercept. So this one would be hard for me to graph because it starts at a fraction. It starts at 3/2. But lucky for us, at least here, we don't have to graph it. We just needed to find the slope number. Slope is 3/8, or 3 divided by 8. So the fast way to find slope, if they give you an equation, is always to solve it for y. I didn't have to graph it. I didn't have to make a big picture and make sure it's perfect and try to find the change in height and change in distance. All I did was rewrite it solving for y. So using those algebra skills to solve for the variable and then knowing, okay, the number multiplied to x, that's my slope. Any questions right now? Concerns? Please. All right. There's one more thing I need to show you. Actually, two more things. And it's already 11:30, isn't it? So I'm going to do this fast. There's two more skills I want to show you. And then we should be totally armed to properly take on this mastery test. So next up, slope formula. Okay. So there's a formula we can use if they give you 2 points, and we can then solve for the slope. Earlier, I showed you how to do it with the graph picture. But what if they just give you the 2 points and don't give you the picture? Well, you could make a picture and graph them and then count up and over or down and over to find the slope. Or we can use the formula. Remember, slope means rise over run. It's the change in the height over the change in the distance. So to find the change in height, we're taking one of the y numbers and subtracting it from the other. Divide by the x number minus subtracting the other x number. So we're essentially saying one y minus the other over one x minus the other. And this is like 0.1, and this one is 0.2. Here's an example. Let's say that we were supposed to find the slope between, here we go, 0, 7 and another point, 9, negative, not negative 2, 9, negative 5. So here's our 2 points. Okay, so we could graph them and then count up and over or down and over to find the rise over run. And that's not bad. You can do that. I want you to do that as well. But I also want you to know how to use this formula. So it's y minus y over x minus x. So look at those 2 points. And we know that the domain, the x numbers are always the first numbers, right? The range, the y numbers, those are the second ones we see. So that means 0 is an x and 9 is an x. 7 is a y and negative 5 is a y. I would label them just like I did here on the screen. That'll be helpful so you don't mix up the numbers when you're using the formula. Slope is y minus y. So 7, look at your points above and then plug them into the formula. Y minus y will be 7 minus negative 5. The number's negative, right? So that comes into the formula. 7 minus negative 5 over, and then x minus x. So 0 minus 9. Now we've got to do some simplifying. 7 minus negative 5 minus a negative turns positive. Double negative turns positive. So subtracting a negative number goes the other direction. So I'm going to turn this into 7 plus 5. And in the bottom, 0 minus 9. Subtracting 0 minus 9 is actually negative 9. So we can kind of think about it as just crossing out that 0. 7 plus 5 is 12. So we've got 12 over negative 9. Now, this is technically our slope. We're technically done. However, it's best to always reduce your fractions. Edmentum is not going to have 12 over negative 9 as an answer. So we've got to try dividing by common factors. So I noticed that 12 can be divided by 3 and 9 can be divided by 3. So I'm dividing the top and bottom by the same number. And that gives me 4 over negative 3. And last thing I want to mention is if when we're working with a fraction and one part, top or bottom, numerator, denominator is negative, the whole thing's actually negative, the whole value. So the proper answer here is negative 4 over 3. So let me write it at the very bottom here. Slope is negative 4 over 3. So we need that formula to find slope if they give us 2 points. Okay, and it's time to start our work. There's actually one more. I know, I'm sorry. I want to do one last thing with you, but it's one I took from Edmentum, and it's a picture. So look at this with me, and you know what? Don't bother copying this. If you want to take a picture with your phone, you can. This one I think is either from the practice or from the mastery test. Kind of a word problem, but they give us 4 different function lines graphed, and they want us to pick which graph goes with this equation. Charlie's Pizza charges $12 for a medium cheese pizza plus $2 for each additional topping. The cost of a medium pizza, y, with x toppings, is represented by this equation. 12 plus 2x. We have to pick which graph goes with that equation. Only one will match up perfectly. So let me write the equation a little bigger. Y equals 12 plus 2x. Remember, the number multiplied to the x is slope. So 2 is slope, and 12 is our y-intercept. Let's start by looking at the 4 graphs and seeing if we can eliminate any of the options based on just the y-intercept alone. We should see the blue line hitting the y-line, the y-axis line, at 12. So option A, that looks like it could be 12, right? It's a little higher than 10 and less than 15. Looking at C next to it, that one is not it because that's hitting just above 5. Probably 6 or 7, right? So it's not C. Just based on the y-intercept. Looking at B below, it looks like that one's at like 2.5 or 3 or something. I'm not sure, but it's something less than 5. I'll call it 3. It's not B because the y-intercept is so bad. It's way lower than 12. Looking at option D, this one again looks like it could be 12. So I think right now I've already eliminated 2 out of the 4 options. So how do we decide? Well, we've got to check the slope now to see which one has a slope of 2. If I look at A graph and look at D graph, the lines aren't quite the same steepness. Looks like the A one is a little steeper, meaning it's a little higher slope. So let's try finding the slope here. Looking at A, I want to pick 2 spots to count rise over run where it's crossing the grid lines. So let's use this spot right here, assuming that's actually 12, which I think we can assume that. So the point would be 0, 12. 0, 12, because it's at 0 below on the X ruler, and it's 12 high. And do we see any other spots where it crosses over the grid lines? This might be a good one right here. See how it's crossing at the dashed lines? Those are units, so we can measure there. So that's 4. How high? Look to the left, 20. 4 comma, that's perfect. I didn't mean to pick 420. 4 comma 20. So how do we find its slope? Let's try the formula. Y minus y, so 20 minus 12 over 4 minus 0. Y minus y over x minus x. So that's 8 over 4. 8 divided by 4 is 2. The slope is 2. So that means A is our answer. Has to be. It has the right y-intercept and it has the right slope. If we wanted to check the slope down below for D, let's see, that is 0, 12. And it crosses again here. And I cut off the bottom. I think that's 8. So that's 8 comma 20. Let's see what the slope of D is just for kicks. So 20 minus 12, y minus y, and 8 minus 0. So 8 over 8, that's 1. So the slope of D is 1. So we can rule that out. We can eliminate that option. That tells us we for sure just want A. It has the right slope and y-intercept. Okay. 20 minutes. A little better than normal. It's better than me talking for a whole hour, right? Open up Inventum, go to Unit 3, and start doing the slope and graphing mastery test. I'm going to put you all into breakout rooms soon. Unit 3, slope and graphing. Some of you have tried this one already. Not everyone, though, so it's the homework for everybody today. Let's try to get a 4 out of 5 on this test, see how we do. Or more. Let's try to get 5 out of 5. Unit 3, slope and graphing mastery test. This is our homework for today. And I'm going to put you all in the breakout rooms now, and I'll come around in a circle. And if you want to work in a small group, just write me a message, and I will put you folks who want to work in a small group together, okay?